right, welcome to part 2 of the cancer notes. Remember, I'm going to talk quickly. If at any time you need to pause this screencast in order to take notes, please do so. All right, we were just talking about how some cancer can be inherited, and now we're going to talk about cancer treatments. A lot of these treatments you will be familiar with. The first treatment that we're going to talk about is chemotherapy. How does chemotherapy work? Well, it interferes with the process of cell division at some point during the cell cycle. It tends to target fast dividing cells. Unfortunately, you do have some healthy fast dividing cells like hair cells and blood cells. So people who are going through chemotherapy often lose their hair and experience anemia because they don't have as many blood cells. Their blood cells start to get attacked, don't divide as much. Another treatment for cancer is surgery. Surgeons may try to remove a tumor. Unfortunately, if any of the fast-dividing cells are left behind, however, the cancer may return. Some of the tendrils from a tumor may be at microscopic level, and so it might be difficult for a surgeon to actually see for sure that they've gotten all of the cancer cells. So they often combine surgery with chemotherapy or radiation to kill off any leftover cells that may have been left behind by the surgery. All right, and then radiation. Have you ever wondered why cancer patients would be treated with radiation? Because radiation causes cancer, right, KJ? Why would they do that as a treatment? Well, it does damage the DNA, but it damages the DNA of the cancer cells also. And so the hope is that a dose of radiation specifically on those cancer cells damages their DNA so much that they can no longer divide anymore. The one disadvantage, and it's a huge disadvantage though, is that it can also damage the DNA of the surrounding healthy cells. So radiation isn't ideal. It's a life-saving technique, but there is often the possibility that cancer would come back because of the radiation itself. All right, let's talk about telomeres. This is a completely different thought and has nothing to do with the treatment of cancer. Okay, what are telomeres and what do they have to do with cancer? Well, first of all, if you look at this picture down below, you see those are chromosomes, and on the tips of the chromosomes are these hot pink or red little points. Those are called the telomeres. Telomeres are pieces of highly repetitive DNA on the ends of the chromosomes. Notice the diagram on the right that shows that the DNA is very repetitive with these A's and C's. So the purpose of a telomere is to protect chromosomes from damage. I heard a scientist once describe telomeres like the plastic tips on the ends of shoelaces. When those plastic tips break, the shoelaces start to fray. Well, apparently telomeres are very similar in the sense that they're protecting the rest of the DNA from damage. And every time that a cell divides, the telomeres get a little bit shorter and a little bit shorter and a little bit shorter and a little bit shorter. Eventually, those telomeres are so short that the cell says, well, we can't divide anymore because we're going to have damage to DNA. So it says healthy cells can only divide approximately 50 times, we learned this earlier, the Hayflick limit, before the telomeres become too short and the cell stops dividing. That's called senescence, when it stops dividing. And then when it dies, apoptosis. We mentioned that word a little bit earlier, or apoptosis is another way to pronounce it. So that's why our cells only divide 50 times, because beyond that, we would have damage to our DNA. Well, there's all kinds of interesting stuff that goes with this. Kids with progeria are born with short telomeres. So their telomeres are already down here, and so right away their cells say, oh, we can't divide anymore, and these beautiful little children age so much faster than everybody else does. So then there's some questions that come up with that. There is an enzyme that is called telomerase. It's an enzyme that protects the telomeres. So instead of the telomeres getting shorter with every cell division, they stay the same length. It allows cell division to continue, and this telomerase, this enzyme, appears to prevent senescence. Senescence is connected with aging. When our cells stop dividing, we get old. And so there's a question about the connection between telomerase, this enzyme, and the aging process. Senescent cells are still alive, but they're no longer dividing, and those are the things that are connected with aging. Most cells, this is weird, you have the gene for telomerase in you right now. You could protect your telomeres and your cells could divide and divide and divide and divide. It seems like some fabulous secret to long life. Most cells, though, that gene is turned off. We inhibit the formation of telomerase. Well, the question is why, and let's get to that. White blood cells, this is why you have telomerase. White blood cells have to divide often, way more than 50 times. So you have telomerase specifically for your white blood cells, your cells of your immune system, so that they can divide and divide and divide and fight your diseases. This is why you have telomerase. Why do other cells inhibit telomerase? Well, inhibiting or stopping telomerase seems to prevent cancer because cells can only divide a finite number of times. So if the telomeres get shorter and shorter and shorter and shorter, after 50 times it stops, and that is a way of preventing cancer. So it's one of these many checks and balances that your body has. Cells can only divide 50 times, you shouldn't be able to get cancer. Well, guess what? Why do we get cancer? Almost all cases of cancer involve a mutation of the gene that stops telomerase. Oh my gosh, that's just too much for me to figure out here. Make sure you get it. Telomerase protects the telomeres. Why do you have it? So your white blood cells can divide. But most of your cells say, nope, can't have telomerase, so that your cells, the telomeres get shorter, and after 50 times they stop dividing. What happens in cancer? That gene that stops telomerase is broken. And so the telomeres stay long, and so they can divide and divide and divide, like Henrietta Lacks cancer cells after all these years. So is there an implied cure for cancer here? Yeah, if we could stop telomerase, if we could figure out a way to turn the telomerase off, then the cancer cells could only divide 50 times, and then the cancer would be over, and you couldn't get this massive tumor from it. Pretty cool ideas. We haven't been able to make it work in a human yet. All right, so what are the implications for this line of research? Of course, this little girl has progeria. Do cancer cells and progeria, children with progeria, hold a secret to increased lifespan? And the answer is probably yes. So here's the future of cancer treatment. Eventually, by studying your DNA, scientists will be able to teach your immune system to eat your cancer cells. Our goal, boy, I'm getting a little awkward here right at the end, sorry. Normally, we get cancer cells. They think that we develop cancer cells and that normally our immune system is supposed to attack those cancer cells. But for some reason, in people with cancer, the immune cells don't recognize the cancer, and so they ignore the cancer. So one thing that we're going to try to do is add little flags onto cancer cells to make the immune system attack them. As usual, we can do it in a petri dish, and we're really good at curing cancer in a petri dish, but the moment we have to try to cure cancer in a person, we're not quite as good at that. All right, that is it for Cancer Notes. Let me know if you have any questions.